Hello friends, in the present video we will solve a problem on earth pressure if there is a submerged soil. Okay. First, let me explain you the question. There is a retaining wall. There is a retaining wall and the backfill is horizontal. Okay, we don't have any problem. And here they have given you that gamma will be equal to 20 kilonewton per meter cube and phi value given as 30 degrees and cohesion is given as 0. So let us assume this is the first case. In second case, in first case there is no water table. Okay. In the second case, consider the same backfill and here they have given gamma saturation that will be equal to 25 kilonewton per meter cube and again they have given phi value will be equal to 30 degrees and cohesion is given as 0 and here the water table is at the top surface and let us consider the height of the retaining wall is 10 meter and here also it is 10 meter and here it is the case 2. In the first case, is there any water table? No. In the second case, there is a water table at the ground surface. So here the question is find the change in active earth pressure. Find the change in active earth pressure if water table rises to ground surface. If water table rises to ground surface. What do you think? In compared to the first case and second case, in second case, what do you think? The pressure will be increase or decrease? My option is increases. You know why? Because if you're talking about only soil, what about the lateral earth pressure? That will be some constant into vertical earth pressure. But coming to the water, whatever the point you consider, in all directions the pressure is same. As we are talking about the active earth pressure, that magnitude will always, I can guarantee that it will always be less than 1 or equal to 1, most of the cases. So except only in cohesion soils, it is equal to 1. Otherwise, in all the cases, it is less than 1. That means lateral earth pressure will be less than the 1 because of the, if you compare with the water. So that's why if it is active earth pressure, I can say that pressure in second case is higher than the first case. Okay. Let us start the problem by considering the first case. If we are considering the first case, let us consider the retaining wall and height of the retaining wall is given as 10 meter. And what about the properties? Cohesionless soil, directly we can apply. Gamma is given as 20 kilonewton per meter cube. Phi value given as 30 degrees. They are asking us to find the active earth pressure. That means for that find out the active earth pressure coefficient that will be equal to 1 minus sin phi divided by 1 plus sin phi. If you substitute 30 degrees in this equation, you will get constant as 1 divided by 3. And how you will find out the pressure at any point? It is directly equal to Ka into how much? Vertical stress. What is the vertical stress? Ka into gamma into Z. Z is measured from the top surface. So let us draw the variation. At the topmost soil, what is the Z value? 0. That's why what is the active earth pressure? 0. As you keep on going below, what happens? Your vertical stress increases. That's why your active earth pressure will also increases. So what is the magnitude? Ka 1 by 3. What is the height of the retaining wall? 10 into what is the gamma given? 20. If you solve this, we will get around how much will get 1 by 3 into 10 into 1 by 3 into 10 into 20, 200 by 3. That will be around 66.67 kilonewton per meter square. In between these two, it is varying linearly. Is that it? Now, what about the total magnitude? Let us represent as it is in the first case. I am representing active earth pressure in first case 1. So it is in the shape of triangle. So what is the area of this triangle? Half into 66.67 into 10. So in first case, you are getting active earth pressure as, if you solve that equation, you will get 333.33 kilonewton per meter. As we already discussed, if you are taking 1 meter length of retaining wall, what is the active earth pressure? Active 333.33 kilonewton. So this is in the corresponding to the first case. Now, going to the next case, what is the given data? Gamma saturation is given as 25 kilonewton per meter cube, and phi value is same, 30 degrees, and the cohesion is equal to 0. And what is the height of the retaining wall? 10 meters. What is the difference? So in this case, where is the water table? Water table is at the top level. Now tell me, what is the difference between the dry soil and the submerged soil? So if you take any point in the soil mass, so the soil mass, soil is also there, and also in between the pores, water is also there. Do you think lateral earth pressure for water and soil are same? No. Why? Because if you are talking about the water, in all direction the pressure is same. But if you are talking about the soil, in all directions you cannot say pressure is same. So that's what we have to do. We have to find out the stress due to soil separately, the stress due to water separately. So let us say, because of the soil only we are finding. Because of the soil, as we are finding, how to find the variation? That will be equal to Ka into sigma V. As we are taking only the soil, here we have to use the effective stress. That will be equal to Ka into gamma dash into Z. What is the gamma dash value? That can be written as gamma saturation minus gamma W. Saturation given as 25. Gamma W, let us consider 9.81. If you solve this, how much you will get? 15.19 kilonewton per meter cube. That's it. Because of the submerged, because of the because of the soil, what about the active stress? Here it is 0. If you keep on increasing below, your stress will increase. And at this point, what is the magnitude? Ka already we have seen 1 by 3. Let us say the active earth pressure at the red bottom. How much you will get? That will be equal to Ka already seen 1 by 3 into gamma dash 15.19 into what is the height? 10. If we solve this, we will get it around 50.63. So in between how it will vary linearly. So this is because of the stress, because of the soil, effective soil. Now in between the pores, we are having some water also. Because of that, pressure will also act. But what is the condition for water? Whatever the direction you consider, for water, the pressure is same in all directions. That's why no need to multiply with any constant. So that's why what we'll do. Here I'll say simply due to water. Why? Because if it is because of water, what is the stress at any point? That will be nothing but simply gamma W into Z. At this point it is 0. And what about at this point? Gamma W 9.81. And what about the Z value? 10. That will be equal to 98.1. So the total pressure, that will be equal to pressure because of the soil plus pressure because of the water. Because of the soil, what is the pressure? Half into 10 into 50.63, as you can show in the question. Plus because of the water, what is the value? Half into 10 into how much you are getting? 98.1. So if you solve this, you will get pressure that will be equal to 743.65 kilonewton per meter. What we have to find? We have to find the change in pressure. In the first case, how much you are getting? 333. In the second case, how much you are getting? 743. That means your pressure has increased. So percentage increase in pressure, that will be equal to pressure in the first case minus pressure in the second case divided by pressure in the first case. That will be equal to, in the second case, right? Second case is larger. 743.6 minus 333.3 divided by 333.3. Therefore, percentage increase in pressure, if you solve that, you are getting around 123%. So if your water table is rises to the ground surface, your stress has increased to 123%. Okay, thank you.